Bismillah ar-Rahman ar-Rahim. This is Dr. Ahmad Al Faris. Today we are going to answer Unit 2 Edexcel Physics, May 2019, Unit 2 Waves and Electricity. This year was the first exam. This exam was the first exam according to the new syllabus after 2018. Okay. As usual, my advice to all the students, they don't start the multiple choice questions. Okay, start from question 11. So we are going now to skip the first 10 multiple choice questions and we are going to start question number 11. Now, why we do that? Because some of these multiple choice questions, they waste a lot of time, okay? And the student, they have high adrenaline. So we have to go to the easy questions, question number 11, 12, 13, okay? And calm down so we can use our highest potential to save time to answer as fast as we can the whole questions. After we finish, we can return back to the multiple choice questions, even if we don't have enough time. Okay, the multiple choice questions, we can read them very quickly and choose the answer, but we can't waste a lot of time because the last two questions, they have a lot of marks on them. We need this time to answer these questions, okay? Any question? Okay, let's say Bismillah. Okay, question number 11. A student carry out an experiment to determine the resistivity of a metal in the form of a wire. She made the following measurements. She measured the length of the wire, the resistance of the wire by ohm meter, for example. Don't forget this is milliohm. That means I have to multiply by 10 to the power of -3 to convert it into, okay, ohm. Okay, and the diameter by a micrometer screw gauge. Okay, and we have to divide it by 2. Then we have to find the area, and it's in millimeter. We have to convert it into meter. All these are reading that they give it to us. Determine the metal of the wire using the information from the table. Now we know that the formula for resistance with resistivity, resistance equal rho L over A, right? And we have to choose what is the resistance here, okay? What is the resistivity, okay, which is RA over L, to find out how much is the resistivity, to pick which material according to the closest number. So the resistance of this material, which is 50 milliohm, that means 50 times 10 to the power of -3, multiplied by the area, which is pi radius square, and this is the diameter, so 0.36 multiplied by 10 to the power of -3, converted from millimeter to meter, divided by 2 to convert it from diameter to radius, all square, because the area is pi r square, all divided by what? By the length, which is what? 0.2. And by using calculator, our answer, it will be how much? 2.5 times 10 to the power of -8 ohm meter. Now, we will look to the table that they give it to us, and we search 2.5 times 10 to the power of -8. Yes, thank you, Hamza. It's what? It looks close to aluminum, 2.7 times 10 to the power of -8. So it is aluminum. Okay, like this we get what? The 3 marks. Any question? Is it easy? Clear? Let's move on. Okay, let's move on. Next question, question number 12, what they ask here. The equation I equal NQVA, or as we said, navy, okay? NAVE, E is the charge for each electron. What do you mean, Shahid? Which one? Which question? Isn't the power -4? Let me check. Okay. The one before. Okay. If we use the calculator, yes, I convert from millimeter to meter here. It's -3, yes, not -4. Because milli divided by 1,000. Okay? Yes. Any other questions? Okay, let's move on. Now, the equation I equal NQVE, okay, can be used to establish the drift velocity V of the electron of a copper wire. State what is meant by the drift velocity. Now, what's the meaning of the drift velocity? Yes, thank you, Hamza. Another answer. Okay, it's the average. What? Bravo, ya Ammar. Average what? Velocity, okay, average velocity of the free electrons or electron conductor, they call it sometimes, because it's the free electrons, they are connecting the electricity. So it's the average velocity of the free electrons. Yes, thank you, Ammar and Hamza. That's part A, easy mark. Part B, a copper wire has a cross-section area. This is the cross-section area, according to the formula, 2.64 times 10 to the power of -7 meters squared, and carries a current of, this is the current, 1.31 ampere. Calculate the drift velocity, okay, of this copper wire, and they give us how much the number of free electrons, okay, per 1 meter cube of copper. And we know that according to the formula I equal navy, okay, they give it to us, okay, we can substitute the values to know how much is the drift velocity, which is I over NAE, and we substitute the values, which is 1.31, the current, divided by 8.49 times 10 to the power of 28 electron density times the cross-section area, they give it to us, okay, times 10 to the power of -7, multiplied by the charge for each electron, and we know that the charge for each electron is 1.6 times 10 to the power of -19, which is a constant value, and eventually our answer, it will be 3.65 times 10 to the power of -4 meters per second. Usually these values of the speed are small through conductors like copper wire, and they are a little bit higher through insulators and semiconductors. So if you find that the value is -3, -4, -5, it's accepted answer for metals. Okay, if you find it in higher speed, that means they are talking about semiconductors or insulators. Any question here? So 3 marks before and 3 marks so far, 6 marks. That means, okay, we have to spend approximately each mark a minute and a quarter or something like this, okay, or approximately a minute. Okay, so we have to run as fast as we can during the exam. Okay, next question, what do they ask? The orbit of planets around the sun are elliptical. Okay, what do we mean by elliptical? Okay, this is, for example, our planet. This is our sun. Sometimes it's close to it, other times it's far from it. Yes, you can take screenshot. Take screenshot. Yes. So what they ask here, the intensity of radiation, okay, received at the top of the Earth atmosphere is monitored during one orbit of the Earth around the sun. The following data are recorded. The maximum light intensity, that means whenever it's closest, here it's the maximum, and the minimum light intensity whenever it's farthest, here it's the minimum position, okay, the light intensity reach the atmosphere surface. Yes, Hamza, yes, your answer is correct. Okay, what they ask here, okay, should we solve you as, okay, now you can take screenshots, okay, you try to answer it before, okay, if you have enough time, okay, I'll keep sending you the papers during the year, okay, during these 2-3 weeks, okay, and you keep trying to answer them, then take screenshots, and if you have any question, you can ask me or make a discussion, and during the exam or at the end of the exam. Yes, Karim, yes. Okay. Part A, what they ask, calculate the minimum distance between the Earth and the Sun. The power of the Sun, they give us how much the power. Now, they ask about the minimum distance. They ask about here, the distance from here to here when the maximum intensity it is. Okay, and we know that this distance, okay, or radius they call it, we have to use what? The formula for light intensity. And we know that light intensity is equal to the power over what? The area, which is equal the power of the sun, they give it to us, divided by the area, okay, because we are talking about area of sphere, okay, which 3-dimensional, which is 4 pi r square. Here is the distance that they ask about it. So the radius is the minimum distance. And this minimum distance happens when the light intensity is the maximum because it's closest to the point. So we will substitute the value here to find how much is R. R equal square root of P over 4 pi I. I make it as a subject of the formula, then I will substitute the values, which is 3.83 times 10 to the power of 26 divided by 4 pi multiplied by the intensity, which is the maximum, which is 1.41, and they said kilo. That means times 10 to the power of what? Of 3. And by using these calculations, I will find out that the answer is 1.47 times 10 to the power of 11 meters. This is the answer. Why you are using the maximum? Okay, now whenever I'm closing the closest distance, they ask about what? Find out the minimum what? Distance. When they ask about the minimum distance, that means they ask about closest point. The closest point, that means the radiation of the flux intensity reach from the sun to the earth. It will be the highest when you are close, not when you are far. So that's why they give us the light intensity, okay, at minimum position at what? Maximum position, okay? So the closer the distance, okay, the higher, the closer the distance, the higher the refractive, sorry, the closer the distance, the higher the light intensity reach from the sun to the moon. I have no problem. I'm not hurry up. I'm not fast because you know that it's very fast. We have less than 2 hours to answer the whole exam. In the reality, we have less than an hour and a half exactly to do the exam. I'm trying to answer it, okay, as fast as possible. Also, if you have any question, I can explain it to you and repeat it, okay? And if you don't understand in the end of the session, I can be with you and explain it to you separately, okay? Any other questions? Any other questions? Okay. Part B, what do they ask here in part B? As Mars orbits the sun, the intensity of radiation received by the top of the atmosphere varies from 491 to 711. So this is the minimum whenever it's farthest, and this is the maximum whenever it's what is closest to the sun, okay? Explain two differences between the orbits of Mars and Earth that can be deduced from these data. Now look here to the values here of the Earth, the maximum and the minimum. It's in thousands, 1.4 and 1.3 thousands. But look here, it's 490 and 711. The difference here, they are close to each other, okay? But the difference here, it's wide, okay? So that means we have major differences here. First of all, we can say that the mass of the Earth is orbit is farther than what than for the Mars it's farther because the light intensity is what is less, and also we can say that it is more elliptical than the Earth because the difference between these radiations is what is greater than for the Earth. So for the Earth, the radiation intensity between the maximum and the minimum, it's not that difference compared to the value of them, but here compared to the minimum and the maximum reach of the Mars, there is a huge value between, for example, 490 and 710. There is a huge difference compared to the original value, okay? So what we can say here, first, that information, we can say that Mars, okay, has greater distance orbit to the sun than the Earth, since the radiation flux or the light intensity, okay, whatever you want, the radiation or the light, no problem, okay, the intensity of radiation reaches Mars is much less. And also, what we can say, this is the first point. Second point, the orbit of Mars has greater curve, elliptical curve, has greater elliptical curve due to the large difference, due to the large difference of its intensity of radiation compared to each other. When we say that's more curved, that means more elliptical. You can write it in different way. You can say instead of has greater elliptical, you can say more elliptical. Yes, more elliptical. Okay, take screenshot for this answer. Now, usually, not all the students, they get full mark, you know that, okay? And it depends on the question, it depends on the year, okay? So we have to write all the information that we have. And if you realize that you are not having the whole informations, you have to put a mark, okay? And check how you can get your answer correctly, okay? Tamam. Okay, let's move on. Let's move on to the next question, question 14. In question 14, it's a star question. What do they ask? In 1921, Albert Einstein was awarded a Nobel Prize for physics, okay, for his discovery of the law of photoelectric effect, okay. To explain this effect, Einstein proposed, okay, that electromagnetic radiation should be modeled as a particle rather than as what? As a wave. So we have to assume that the light is as a particle rather than as a wave. Explain why, when considering the photoelectric effect treating, okay, electromagnetic radiation. If you please put mute, if you please, all of you. Thank you. Explain why, when considering the photoelectric effect treatment of electromagnetic radiation as a particle is more successful than as we treat it as what? As a wave. Now, in this question, because we are talking about a star question here, we have to realize that we are not going to give them all the informations we are also give them ideas that we have to link them together, okay? And these ideas we have to what? To put them, okay, to as linkage, because according to the new syllabus, you have to write all the informations, okay? And you have to put them in a sequence that make a good relationship between them so you can understand what the question is asking or answering for. What they ask here. I'm sorry, by mistake, I sent a message for you. Okay, by mistake, my mistake. I'm sorry. Okay, so what we have to say. First of all, we have to know that light consists of what? Photons. And photons, okay, each photon has energy depending on its what? Frequency. And each one photon, it will interact only with what? One electron. Okay, that's the particle theory. Okay, and if, yes, thank you. And if the energy of the photon that interacts with one electron is greater than the work function, the minimum amount of energy that needed to release electron, to liberate electron, that means this electron will be free to move with kinetic instantaneously, with kinetic energy maximum according to the difference between the work function and the energy of each photon. And this kinetic energy has a certain limit. That's why we call it what? Maximum kinetic energy. Okay, that's about particle theory. But if we talk about wave theory says that light intensity depends on its energy, and whenever the light intensity is greater, the energy is greater. And whenever the frequency or the wavelength of the light is shown on a certain metal, okay, eventually after the energy is built up, the electrons are liberated. It doesn't matter, okay, how long it is, but the energy it will build up, okay? And that's not correct also. And also we have to say that, yes, thank you, Hamza. And also we have to say that here in wave theory, that the kinetic energy of liberating electrons, okay, they don't have maximum value. It depends on the energy of the light intensity. Whenever the light intensity is greater, the kinetic energy will be greater, and there is no certain level of maximum value for that. And that's not explained by wave theory, because that's not happening, okay? According to the particle theory, we have to mention what are the differences. Now, the introduction of explaining this photoelectric effect, okay, about the light and how the light consists of energy and photons and etc., and work function and make relationship, all these you have to write it down, okay? Now, if we look to the mark scheme, they are give you that certain points that they are going to give you a mark on it. Now, you cannot take the you cannot write down the answer from the mark scheme without explaining the introduction that I'm just explained, or I just say it, okay, before, because this introduction give the examiner, okay, a good relationship for the linkage between the ideas, okay, when you write it down. So if you don't have this connection between the ideas, the sequence between the ideas, you'll not get the marks. So if we look to the answers here, okay, in the mark scheme, you will see that, okay, as I told you here, we have 6 marks on the 6 ideas, only 4 marks, then 2 marks on the linkage, and sometimes they give you what are the linkage. Look here, the ideas that they give you the 6 points, okay, 4 marks on it, that there is minimum or threshold frequency required to release electrons, okay? For wave, any frequency can be able to release electrons. That's not correct. Release electrons from is instantaneous according to the particle theory, but in wave model, okay, it will take time to build up energy to release the electron, and that's not correct. Finally, the kinetic energy of released electrons depends on the frequency, and it has a maximum value. But if in the wave theory, okay, where it's correct, the kinetic energy, okay, of the released electron depends on the light intensity, and it doesn't have a certain maximum value, okay? Any question? Now I'm going to write down the answer. What does the light intensity affect the kinetic energy? Now, actually, no, it doesn't. As the light intensity increases, that means the number of photons will increase. That means the number of electrons, okay, will be replaced, will be more, but that does not increase the kinetic energy, okay, of the electrons, okay? Okay. So if I'm going to write down an explanation for this, okay, how I'm going to write it down? I'll start by introduction about what do we mean by wave and particle theory, and what do we mean by light. So what we are going to say, light consists, if you please put yourself mute, thank you. Okay, okay. Light consists of photons, and each photon has energy due to its frequency. Okay, according to which formula? Energy for photon equal Planck constant multiplied by what? By the frequency. One of the questions, one of the students said it now, teacher, if I wrote that at the end of the particle theory, it's correct, wave theory is an incorrect conclusion. Instead of writing these points, no, you have to tell them what's the correct and what's the incorrect, what's the particle theory and what's the wave theory. Suggest, okay? Good. Okay. Light consists of photons. Each photon has energy due to its frequency, and each, if you please, can you put yourself mute? Thank you. Yes. Ragat, mute if you please. Okay. Thank you. And each photon, okay, will interact with only one electron. Okay, Raghad, I am sorry. I will. Okay, this is the last time. Thank you. And each photon will interact with only one electron. So, as the light is shown on a metal with frequency higher than the threshold frequency of the metal, threshold frequency of the metal, the electrons are emitted instantaneously with what? With kinetic energy, okay, maximum, has maximum with kinetic energy, which has a maximum value, depending on the frequency of the photon, and the position of the electron. And by increasing the light intensity the number of photons increases, so more emitted electrons every second. All of this is due to what? Due to the particle theory, or due to the particle model. But the wave model suggests that light energy depends on its intensity, so at any frequency electrons can be emitted the position of the electron, if it on the surface exactly, the first energy level, second energy level, okay, or inside down. So whenever they have different energy level and several position of the electron of the atom, is it on the surface or on the second layer, so the kinetic energy of liberated electrons will be different, okay? So at any frequency, electrons can be, okay, emitted. As the energy is built up, after a while. Okay, with different range of kinetic energy as the light intensity increases. As the light intensity increases, which is not correct. Okay, can I only write 5 points, Mr.? Okay, if you write 5 points and these 5 points was correct, how many marks you are going to get? How many marks? Now, I said that in 5 marks, okay, you'll get 3 marks on the writing the points and 2 maximum marks on the linkage between the 2 marks. It's not me who checking the exam. It's according to the laws of Pearson Edexcel. Okay, so as we can see here on the mark scheme, they put, okay, if you write the 6 ideas, the 6 points, you get 4 marks. If you write 4, 5 points, you get 3 marks, okay, and etc. 2 marks, okay. Type. So it depends, okay, and the other 2 marks, the extra 2 marks here, okay, on the linkage, if they are okay, they said here there are other 2 marks if your language is common sense language, it's obvious and it's clear, okay. تمام. Okay. I can't hear something wrong on the Microsoft. Yes, on the microwave or microphone. Okay. Yes, of course you can take a screenshot. This is the whole answer. Take a screenshot for it. Okay. One of the students, I don't know who is. Okay, he has a problem. Okay, with his microphone. So if you please, tell me who he is, so I can send him a message directly, so he can turn off his microphone. Okay. Teacher, the electrons will be released from the first layer, then the second, then third. Okay, no. It will be ejected directly out of, because it's greater than the work function. You are talking about something called energy level. That's something else. Okay. So it depends on where the photon reach. Okay, maybe reach the electron. Okay, or the atom in the first layer or second layer or third layer or first or second or third energy level. It depends. Okay, where the photon reach. Okay, and it will interact with one electron. Any other questions? Is it clear? Okay, let's move on. Okay, let's move on to the next question. In question 15 here, what do they ask? In question 15, okay, resistors are included in circuits that are used as potential divider, okay? And we know that potential divider, that means usually they are connected in series. And when we have resistors that they are connected in series, they divide the voltage, they share the voltage between them, okay? So what they ask here, A, drive the equation that the combined resistance R total, okay, of two resistors R1 and R2 are connected in series. Now we know that the formula R total is equal R1 plus R2. Okay, we know that, but we have to drive it down. And we know that they give us a hint that the voltage is divided between them. Okay, so when we say that the voltage is divided between them, that means that the voltage total voltage equal what? Equal the voltage for the first resistor plus voltage for what? For the second resistor. And we know that the voltage, okay, because they are connected in series, that means they have same what? Same current, okay, and the voltage is divided, but the current is the same. So that means the voltage, as we know, which is equal to, okay, if you please put mute, Rima, Ruba, anyone, okay, please mute yourself, thank you. Okay, I multiplied by R total equal I multiplied by R1 plus I multiplied by what? R2. And since the current is the same current, okay, that means we what? We can take off the current from each of these equations. Yes, okay, and that means R total equal R1 plus R2. And that's how we can get the 3 marks of this easy question. Yes, Shahid, of course you can take screenshots. Take a screenshot for the answer here. Okay. Okay, next. Now, that's how we can get what? The 3 marks for driving the formula for finding the combined resistance in series. Okay, part A. Part B. The diagram shows a circuit that includes a resistor combination, okay? The battery here, okay? The diagram shows a circuit that includes a resistor combination. The battery has a negligible internal resistance here, okay? And we have, as you can see, 6 ohm in series, 8 and 16 are in series, and they are in parallel with R unknown resistor R. All the circuit are in series to each other, okay? Teacher, where are the marks of the, okay, look to the mark scheme, okay? I'm not going to deal with how the marks are supposed to be, but the first mark is here, the second mark is here, the third mark is here. That's it, 3 marks, okay? I don't want to waste time, Rahal. If you have any question, you can put it on the end of the session. Okay. The diagram shows this, a circuit that includes the resistor combination. Ala, if you please put yourself mute. Thank you. Okay. The diagram shows. If you please mute yourself لو سمحتي علاء or علاء. Okay, thank you. Thank you, علاء. Okay. Yeah. Okay. تمام. The diagram shows the circuit that includes this combination of these resistors. The emitter display a current of 0.5 ampere. The current here is 0.5 ampere. Okay, that means the current is the 6 ohm and in the 7 volt battery, it's 0.5 ampere. Now the current is divided through this connection in parallel. Okay, calculate the resistance are 3 marks on it. Now there's several ways to answer this question. Okay, there's a logical, mathematical, and physics. You can do whatever you want. Now we know that the combined resistance of the whole circuit can be found by knowing the current, which is 0.5, and by knowing the voltage. So the first step, we know that voltage total equal current total multiplied by R total. Okay, that means the voltage total, which is 7, equal 0.5 multiplied by R total. And that means the R total, it will be how much? It will be 14 ohms. This is the first step. Second step, now we know that the R total, okay, it's going in series circuit from 6 ohm and the combination of these all. So it's equal 6 plus what? R in parallel, okay, these and these, okay. Tamam. So the 14 minus 6 equal R in parallel. Okay, that means R in parallel, it will be equal 8 ohm. Okay, this is the second step. The third step, okay, what we are going to say? We are going to say that the R parallel, it's equal to R, the unknown, times the R in series, these two, over R, the unknown R, plus what? R in series, because we know that if we have two resistors in parallel, we said R1 times R2 over R1 plus R2. Now R in series, we know it's 8 plus what? Plus 16, okay? So 8 plus 16, R in series, which is 8 plus 16, which is 24, okay? We will put it here, and R parallel, we just find it out, which is 8. So 8 equal R times 24 over R plus 24, okay? And we, by doing cross multiplication and put R in one side of the equation, we will find out that 8 times R plus 24 equal 24 R. Then we divide this, and finally we get our answer, which will be 12 ohms. The unknown resistance will be 12 ohm. Okay. How what? Okay. So 8R, okay, you move it to the other side, it will be minus, so it will be 24R minus 8R equal 8 times 24, divide by 16, divide by 16, we get the answer. It's math. Okay, let me repeat it for you here. No problem, I'll repeat it for you. By doing cross multiplication, 8R plus 8 times 24 is equal 24R. Move 8R to the other side, so it will be 24 minus 8 multiplied by R, which is 16, equal 8 times 24. Divide R equal 8 times 24 divided by 16, which will be 812. Okay? Is it clear now? Okay. I know that it's supposed to be more than 3 marks, but they put only 3 marks. That's it. 3 steps. They want to see what are these 3 steps. Okay, on the mark scheme, we have different range of the answers, and you can see that they put you different ways to answer this question. I prefer this way. It's easy because you can go from the major to the minor, from the whole circuit to the part of it. Good. Any question here? Okay, let's move on to next part, part C. Okay, in this part, part C, what do they ask? Okay, the circuit shows what shown below, okay, includes a light-dependent resistor, LDR. The battery has no internal resistance. Okay, here we have no internal resistance, and here we have what light-dependent resistor connected in series with the fixed resistor. Okay, in normal day light, okay, this particular type of LDR has a resistance of how much? 670 ohms. Okay, calculate the power dissipated, okay, in the fixed resistor and during the normal what day. The resistance of the fixed resistor is how much? 8 kilo ohm, 8,000 watt ohm. So we have to know that these two are connected in series. So the power dissipated, we can find it by different ways. We know that power equal I square R, or we can find it IV, okay, or V square over R, whatever the value you have to use, okay, but you have to make sure that the current or the voltage or the resistance of the what? The fixed resistor, because they ask about the fixed resistor, we have to know how much it is by using this formula. So first of all, we know that they are connected in what? We are connected in series. So what I will do here, I will say that resistor in series, it's equal to 8,000 ohms, okay, plus 670 watt ohms. Why I do that? I need to find the combined resistance in series so I can find how much the current passed through the circuit. So it will be 8,670 ohms. Okay. Second step. Okay, I know that V total equal I total multiplied by R in series or R total. Okay, it's R in series or R total is the same thing. Yes. So the voltage here, which is given 12, okay, it's equal to the I total that we want to find it out, multiplied by this value, 8,670, okay? Then what I will do, I will use this value, okay, to find the power. The power, okay, dissipated equal I square multiplied by the resistance of the fixed resistor, okay? So I, which is this value, 12 over 8670 by doing square on both of them, multiplied by the fixed resistor, which is 8,000, okay, and the answer will be how much? 0.015 watt, or you can write it 1.5 times 10 to the power of -2 watt. This is one method to answer the question. You can use whatever you want. You can find how much is the shared voltage for this one only and use this formula. V square over R. It's your decision. Is it clear? Any question? Okay, good. Next, double I. What do they ask here in this double I? As the light intensity, okay, how do you the current is the same? Now, of course, the current is the same because they are connected in series, but I find only the power of what dissipated through the fixed resistor. Yes. Okay, Shahid? You have to study that and know that you have to know that in series they have the same current. Yes, not like in parallel. In parallel they have same voltage or potential difference across them. Yes, thank you, Shahid. Okay, double I. As the light intensity incident upon the LDR decreases, the power dissipated in the fixed resistor what decreases. Explain why the power in the fixed resistor decreases. Your answer should include reference to the electrons and what and the LDR. Now we have to know that as the light intensity decreases, that means what will happen here? The light intensity decreases, that means the number of free electrons, okay, that can be flow through this semiconductor, the LDR, which will be what? It will be decreased, okay? So that means the resistance of it will be higher. Yes, thank you, Ammar. Yes, thank you, Hamza. The resistance of it will increase the resistance of the LDR. As the resistance increases, that makes the combined resistance of these two in series increases. So make Thus make the current through the whole circuit decreases. And since we use the formula power equal I square R, so as I decreases, the current decreases through the whole circuit. That means the current square also decreases. So that means the power also will be less and less. Okay, good. Yes, thank you, Amar, and thank you, Hamza. So what we're going to write down here. Okay, as the light intensity decreases on the LDR, its resistance increases. Its resistance increases due to the decrease of number of what F electrons, due to the decrease of number of free electrons. Free electrons pass through it. Pass through it. So the combined resistance in series what happened to it? Increases. Okay, increases, making the current of the circuit, the current of the circuit decreases and the power dissipated across the fixed resistor decreases, since the power is proportional to the current square. P equal I square R. Any question? Any question? Is it clear? Okay, let's move on to the next question. You are welcome, Shahid. In question 16, that talks about photoelectric effect. Okay, sorry, the energy level. I'm sorry, energy level. In 1857, okay, yes, I need to take screenshot. No problem, take screenshot. Okay, you are welcome. In 1856, Heinrich, okay, Giesler, one of the scientists, okay, invented the first gas discharge tube, a sodium gas discharge tube, okay, is shown. Most of the electric lamps in our streets, they are actually sodium gas discharge, okay, tube. Okay, that's why they look yellow, because the most common color that come out from it, this gas, sodium gas, is yellow color. Okay, when a high potential difference is applied between the electrodes, okay, these electrons, okay, electrons move through the sodium of the gas of this tube. Electrons will collide with the sodium atoms. The tube then give out visible light with wavelength of how much? 589 nanometer. Okay, nanometer means times 10 of -9. Nano means -9. Okay. A. Describe the process by which visible light is emitted from sodium atom. Now look here, what do we have? Now I told you, my students, several times that we have three ways to make the electrons get excited. By heating it or give it energy by changeable electromagnetic field, okay? By colliding it with electrons, okay? Or by absorb energy by certain frequency photons, okay? Discrete photons frequencies, okay? Now here we have, okay, the neon lamp and also old neon lamps, okay? The same idea. We have two electrodes that keep projecting electrons, and these electrons, they hit the other electrons that from the gases of sodium inside, okay, it on the ground state, for example. And as they hit it, these electrons go to a higher energy level. That means it gets excited. Yes, thank you, Rahad. That means it gets excited. And as it goes to a higher energy level, it gets excited. Okay, this atom is not stable anymore. These electrons, they need to go back down to a lower energy level or to the ground state. Okay, so as they go back down to the lower energy level, they have certain path, okay, to go down a discrete amount of energy, and this discrete amount of energy, the electrons will release it. The electrons will release energy as photons, and this energy of the photon equal to the difference between the energy levels, okay, that the electrons take as it go down. Okay, one of the answers that Hamza write it down to us: energy, okay, energy gains energy and gets excited. You mean electrons? Electrons gain, okay, energy and get excited and move to a higher energy level. Then it go to de-excited, okay, and lose energy to be more stable, to go to a lower energy level, okay, and will follow a certain path, depends on the energy release, okay, by the electron, and each electron will release a photon, and this photon, I will continue your answer. This photon has energy depends on the energy levels, okay, or the difference between energy levels. So you get 2 marks. You didn't mention how much the energy of the photon depends on what. So what we are going to say: electrons of sodium, okay, gain energy by the collisions of the electrons and go to a higher energy level. As they get excited. Then the electrons, okay, move back down to a lower energy level by several paths, okay, and they release energy by emitting photons, have energy equal to the energy level between as it falls to the equal to the difference between energy levels. Sorry, equal to the different in energy levels. Different in energy levels. Okay. Why does the electrons move down? Okay, now the electron, it's supposed to be in the first energy level. Yeah, for example, this is the nucleus. Okay, this is the first energy level. For example, the electron is here. Okay, it's a stable electron. As the electron go to a higher energy level to here, that means the electron is not here anymore. So that means this atom is unstable. So there is an empty space here. So the electron is supposed to go to a lower energy level. Okay, tamam. Did I answer your question? Okay, so to be more stable. Okay. Then what they ask in part B? In part B, they ask us, okay, calculate the energy in electron volt of the photon of visible light with what? With a wavelength of 589 nanometer. Now we know that the energy for the photon is equal Planck constant multiplied by the frequency. And since we don't have the frequency, we know that the speed equal frequency times wavelength, and the speed is the speed of light, right? So what it will be the formula? Energy for the photon equal Planck constant times speed of light divided by what? The wavelength. So we substitute the values here, which is the Planck constant, which is 6.63 times 10 to the power of negative 34 times the speed of light, which is 3 times 10 to the power of 8, divided by the wavelength, which is 589 times 10 to the power of negative 9 nanometer to meter. By doing this, we can find the answer in joules. And the answer in joules, it's 3.38 times 10 to the power of negative 19 joules. Now, they didn't ask about the energy in joules, they ask about it in electron volts. So that means we have to convert it from electron volt to joule. We have to divide this value by the charge for each electron, which is 1.6 times 10 to the power of negative 19. Yes, thank you, Shabab. Thank you, Ammar. Thank you, Hamza. Okay, and the answer by using calculator, it will be 2.11 electron volt. You can take a screenshot here if you want for both parts A and B. Okay, any question here? Is it clear? Let's move on. Okay, in part C, this is a smart question. In part C, what do they ask? Light from the tube was directed through a diffraction grating labeled, okay, as having 300 lines per millimeter. 300 lines per millimeter, that means 300,000 what lines per meter. So 300 lines per millimeter, 300,000 lines per millimeter. So I add 3 zeros to convert it into meters. The diffraction pattern produced was displaced on the flat screen. Okay, the student measured the distance as between the central maximum and the first order. Okay, on the screen, he also measured the distance d between the diffraction grating on the screen. Determine whether the labeled diffraction grating 300 lines per millimeter was correct or not. So again, what they ask, this is the diffraction grating here. The light comes from here. Okay, now the light, as they told us, it passed until it reached the screen. Okay, this is the distance d from here to there. Okay, and he said that, okay, the light make this zero order here and the first order somewhere here. Okay, the first bright fringes after the first maximum, zero maximum. And he measured the distance from here to here, which is what? Okay, the distance d and the distance s. Yes, this one. He measured it also. And he gave us the wavelength. He will ask us how much is n. Now we have to know that the formula for the diffraction grating, which is given, okay, n lambda equal d sine what? Theta. Now this angle is theta. I know the opposite I know the adjacent. So theta equal tan inverse for the opposite, which is S, over the adjacent, which is D. And they didn't ask about D. They asked about the number of lines per unit, per millimeter in the diffraction grating. They didn't ask about how much the separation distance between each diffraction to the each diffraction grating to the other, each slit to the other. So 1 over n sine theta, that we just find it out, equal n, which is 1, the first order, multiplied by the wavelength, which is 589 times 10 to the power of negative what? Negative 9. So by finding this first step, and this is the second step, okay, tan the opposite, which is S, which is 0.2234 over D, which is 1.3. Okay, we'll find how much is this angle. Okay, and we substitute this angle to be here. Okay, the value of the angle theta, I'll substitute it here. Then I'll make n as a subject of the formula, which is sine theta over 589 times 10 to the power of negative 9. And by using the calculator, my answer, it will be, yes, thank you, Ammar. It will theta, which is 10.2, yes, 10.2, and the answer will be 30,100. Okay, sorry, 301,000 lines per meter, which is equal 301 lines per millimeter. So yes, it is correct. (300 lines and 301 lines, they are approximately the same. Maybe he did a mistake by measurements. Okay, 1.3, or it's not 1.3 exactly. Yes, thank you, Hamza. Thank you, Ammar, for your answers. Any question? Zain Khadr, what's the difference between what they ask and the value D? D, okay, is how much the distance between the slits to the other slit, the gap to the next gap, how much the distance between them. They didn't give us how much the distance, okay? They ask about how many gap in each 1 millimeter. Okay, we have several gaps in the diffraction grating. How many gaps do we have in this 1 millimeter? Okay, this is the opposite of D, which is the distance between gap to the next gap. Okay, did I answer your question? You are welcome. Question 17. What do they ask? A teacher set up a signal generator connected to 2 loudspeakers as shown. This appears to be used to determine the speed of sound in air in an open space. A measuring tape was positioned along the ground, okay, at XY here, okay, which was perpendicular distance 3 meters from the 2 loudspeakers, okay. The signal generator, okay, the signal generator was set of a frequency of 160 hertz, okay. The students walked along the line XY. As they walk, they heard a series of maxima, minima, loud noise and quiet noise, okay. As the student, okay, hears the loud sounds, okay. At O exactly, he hears the loudest sound, okay. Okay, explain why the student hears a loud sound at O. Who can tell me why the O is the loudest sound? One of the answers, because both waves from the 2 speakers interfere to each other in phase where the path difference are 0, they make constructive interference. Exactly, it's in the middle. So the distance from the first speaker to O and the second speaker to O is the same distance. That means the path difference between the wavelength here and the wavelength here is the same number of waves, so the path difference would be 0. So that means they are in phase, make constructive interference. Thank you, Ammar. Thank you, and thank you, Hamza Rahal. Yes. So the distance from O to both speakers are the same, making the path difference of the waves reach O is 0. So the waves meet in phase to produce constructive interference. Okay. Of course, you have to write constructive, not const dot interference. Constructive interference. Okay. I make this short between me and my students. Okay. Tamam. Is it clear? Okay. Now look to the picture here. The distance between the two loudspeakers are 5 meters. The separation distance between the screen or the measuring tape and the speakers are 3 meters. Okay. What do they ask here? Look, this is a unique question actually. Part B. As the students move from O towards Y, a sound becomes quieter until minimum is reached. The minimum, the quietest sound is reached, the first minimum. One student stood still in the minimum point while another student would record the measurements by measuring tape. The distance from O to which is recorded here was 84 centimeters, 0.84 centimeter above or below, or it doesn't matter. Determine the speed of sound. How come? How do they ask? Look here. Now this is the measuring tape. This is point O. He moved upwards until here, for example, with a distance of 0.84 meter. The two loudspeakers, one is here and one is here. The distance from here to here is 3 meters, and the distance from here to here is what? 3 meters, and the separation distance between them is 5 meters. And that means this distance also is 5 meters. So that means O, it's 2.5 meters from each side, 2.5 centimeters. So how much left here if I subtract, yes, thank you. If I subtract 0.85 from 2.5 meters, that means here it will be 1.66 meter left, and the distance from here to here, all this distance from here to here, I add 2.5 to 0.84, it will be 3.34 meters. So that means the sound comes from here to here, and the wave come from here to here. Since this is minima and this is first minima, they are antiphase by how much? Half wavelength. They are antiphase by half wavelength. So I need to know how much is this distance. I will call it first path. I will call it path A, and this distance I will call it path B. The difference between path A and path B, it's half wavelength. If I know the wavelength and I know the speed, the frequency from beginning, it's 160 hertz. From the beginning of the question, they give us that the frequency is 160 hertz. And I multiply both of these, I can't find out how much is the speed of sound in air. So speed of sound in air equal the frequency multiplied by what? Wavelength. So 160 multiplied by the wavelength. I have to know how much is the wavelength, which is the path difference. So first of all, I have to know how much is the path difference for how much the path of A. And we know that A equals square root of this. We have a right angle triangle here. We have a right angle triangle here of what? 3 square plus 1.66 square under square root, which will be 3.43. Yes, thank you, Shabab. Allah ya'tikum al-afiyah. That's for part path A. For path B, we have to do the same thing to find how much it is. It's 3 square plus, yes, plus 3.34 square, and by using calculator it will be 4.49 meter. Then the path difference between A and B, it's supposed to be half wavelength because it's minima destructive interference, not constructive interference. So B minus A is equal a wavelength divided by 2. So lambda equal what? 2 multiplied by the path difference, which is 1.06. That means the wavelength, it will be 2.12. I will put it here, 2.12. And by using calculator, the speed of sound in air is 339 meters per second. This is an amazing question, actually. Yeah, for example, we know that here there is 0 lambda. Here we have half lambda because it's minima. Okay, and the minima here, that means they are destructive interference, and we have to use Pythagoras theorem to find how much the path A and how much is the path B. Okay, from here to there. Okay, the same thing from here to there. Okay, and this path difference, it's half wavelength because it's minimum. Any other questions? A lot of chat here that helped me. Okay, why it's destructive? Because it's minimum. Okay, it's destructive interference because it's minima, not maxima. Constructive interference, it will be maxima. So it will be one wavelength if they say constructive. So that means the path difference, it will be one wavelength difference. So the path that come from A and the wave that come from B, they meet at this point, causing what? Destructive interference. It's quiet. They said quiet, not loud. Did I answer your question? Is it clear? I know it's tricky. It's an AS exam, Edexcel. Why they make it easy? The student that they get A is not the same as they get B. Okay. Let's move on to the next part, double I of this question. In double I, what they ask here. The teacher suggests using a microphone, okay, connected to the oscilloscope to determine where the loud and where the quiet zones, okay, were located along XY. She said that by this method would result of a much less uncertainty than when a student walk along the line XY. Now, actually, it's clear. It's obvious. Now, microphone, the dimensions of it, it's smaller than the size of your head or the ears, okay? So you can be a high percentage uncertainty, okay, to find where is the location of the distance, okay? Because when you measure the distance, do you measure from your first right ear or second ear, okay, or from the center of where your head is? It is because maybe constructive or destructive interference, one happened on the right ear and one happened on the left ear. We don't know, we are not sure. So that's why it's not accurate to do by student hearing, okay? By microphone, it will be what? More accurate. It's 2 marks here. What we are going to say, for example, we can, if I look to the mark scheme, we have several. I remember that we have several answers of this question. Let me check, show it to you. Okay, where is it? Yeah, this one. Look here, what they ask. Okay, heard by a person to judge when a sound is quiet or loud. It's not that accurate because as the amplitude of the oscilloscope to determine it's more accurately, okay, for the amplitude or maximum or minimum, okay? That's one suggestion. Another suggestion, the distance between the ears is greater than the size of the microphone, or the size of the microphone, as I said, is smaller than the distance between your ears. So this percentage uncertainty of the distance measured are taken, okay? The microphone, okay, at the same level at the tape, okay? Measure whether the ears are higher, okay? The distance measured will be different from what? True distance to the ears, okay? I prefer this answer. I prefer this answer. It's more clear and more close to the students to understand that the microphone dimension edge smaller than the distance between the ears. So less percentage uncertainty, okay? So less percentage uncertainty of measuring the distance. So less percentage uncertainty of measuring the distance. Of maxima or minima. Is it clear? Okay, one of the questions, can you repeat explaining what's happening here, Ustad? Okay, for example, this is the head of a person, okay? You know that the head of the person is big, okay? Approximately 20 centimeter wide, okay? From the left ear to the right ear. Maybe constructive interference happens to one ear and destructive interference happens to the second. But the size of the microphone, it will be 2 or 3 centimeter. That's small. So the dimensions, okay, it will be more clear and more exact when you measure the distance, because you are not measuring this distance, okay, and how much plus or minus into the head, we don't know. Okay, we are measuring more accurate value to measure the exact distance to where is the microphone it is, okay? So we are more accurate. Good. Did I answer your question? Okay. Next, part C. What they ask in part C? The students suggest that equally valid results would be obtained if the experiment was performed in a classroom. Criticize this suggestion. Okay, if we do that in a classroom, okay, not in open area, that means there will be an echo. There will be reflection from sound from several walls, and okay, which is make hard for us to find where's the maxima or where's the minimum, okay, where there is interference or where's constructive or destructive, because that means there is more reflections, not only from the two speakers, from several walls. So there is more sounds. That means that makes it will not be clear where's the maxima and where's the minimum. Okay, sound is reflected from the walls making more than 2 waves meet at a certain point, so it is hard to find a maxima or minima. Okay, find maximum or minimum positions. Okay. Any questions so far? Okay. Let's move on to question 18. Okay, we have 2 questions left. In question 18, what do they ask here? An endoscope is a medical device that can be used to see inside a digestive system. The endoscope contains a bundle of a very thin glass fibers. Okay, light is directly into the fibers. To eliminate the part of the digestive system being investigated, light travel along the glass fiber by total internal reflection. Okay, these 3-4 lines, they give you informations that you have to understand how the endoscope work. Okay, every time they give you these instruction, this information, that means you are now you are now scientist. You have to know all these information and how you are going to use it. Now, because we know that about the endoscope since IGCSE, it's easy for this question for us. But if they bring a new idea, it would be a little bit complicated. Okay. Now, state the conditions required to the total internal reflection to occur. Yes, Ammar and Hamza, thank you. That means we have two conditions: that the light is supposed to be passing from a high refractive index to the surface of low refractive index with an angle of incidence greater than the critical angle. Light travel to the surface from a medium of higher refractive index to a lower medium with angle of incidence greater than the critical angle, greater than the critical angle between them, critical angle between them. Okay, that's first question. It's actually easy, this one. Okay, part B, what they ask. A ray of light is incident into the end of the glass of fiber, okay, and refracts as it enters the glass. Explain why light refracts as it enters the glass. As it enters the glass here, why does it refract? Because it was moving from air to glass, so from lower refractive index to a higher refractive index. That means there's change in the what? In the speed. As it changes the speed, that means also the direction what changes, okay? Since the refractive index changes, so the speed changes, okay, and it slows down in the glass, making okay the wave changes its direction, okay, as it enters the glass. One of the answers is too long. 1, 2, 3, 4, 5. Oh, I don't know how why you write all these answers here. Okay, it's very easy. Don't write the whole thing here like this. Okay, if you please write only terminologies, keywords, small ideas. Okay, so I can read it because I can't read all this. Okay, thank you for your participation here. Take screenshot. Okay, next part here. Look what they ask here in this question. Okay, the diagram shows a ray of light being totally internally reflected in one side of the glass fiber, okay, and then refracting as it leaves into the end of the fiber. the angle of incident at the boundary between the glass fiber and the air is equal to the critical angle here. Okay, تمام. And the angle of incident to the boundary between the glass fiber and to the air critical angle to, okay, then the ray enter the water and leave out, okay, a glass fiber. So what do we have? We have air here, we have glass fiber here, okay. As the light reaches the boundary between the glass and the air, it is with the critical angle, it bounces back, okay, reach the surface of the water and refract with an angle of what, theta here, okay. And they give us the refractive index of air, refractive index of water, refractive index of the glass. Determine the angle theta between the emerging ray and the normal. Now, first of all, we have to know how much is I, which is the critical angle, because this I in the first surface in the glass, it's equal to what? To R in the first surface. Then we have to know that, okay, this angle, okay, R, okay, I will use it to find how much is this angle I in the glass in the second situation. Then to find how much is R in water in the second situation, okay? So the relationship between R, this one, and I, this one, okay, that these are complementary angles because both of them have supposed to be 90 degrees, okay, because we have a right angle triangle here, as you can see. So first of all, we are going to write N what glass sine critical angle, okay, is equal to N air sine what? 90 degrees, because whenever there is critical angle, it will be 90 degrees in the other side, okay? So that means N in the glass, which is 1.5 sine critical, equal N for the air, which is 1, multiplied by sine 90, which is 1. That means the critical angle, it will be sine inverse for 1 over 1.5, okay? And by using the calculator, it will be how much? It will be 41.8 degrees, okay? So, yes, thank you, Ammar. This is what I in the first situation, okay? So I will use it, okay, to find I in the second situation. So I in the second situation equal 90 minus what? The critical angle, which will be equal to 48.2 degrees, okay? Then I will use it to find how much is the angle theta, which is R in water. So in glass sine I in the second situation, okay, which is 48.2, is equal to N what? Water sine what? R2, which is theta. So here theta sine theta multiplied by water, which is 1.3, equal N glass, which is 1.5 sine what? 48.2. By using the calculator, sine inverse theta equals sine inverse for 1.3 sine 48.2, all divided by 1.3 G brackets. By using calculator, our answer will be 59.3 degrees. So you can write 59 degrees. Any question here? Is it clear what we did here? Is it clear? Okay, thank you. Is my calculations correct? Are my calculations correct? Okay, thank you. Thank you. Question number 19. In this question, what do we have? A student carry out an experiment to determine the EMF, okay, and the internal resistance of what? Of a potato cell, okay? He bring a piece of potato, put 2 electrodes of 2 different materials, okay, and he measured the voltage and the current passed through them to measure how much is the EMF of this potato cell and the internal resistance of it. The potato used in the experiment was connected to the wrist okay, of the circuit using what electrodes of two different what materials as shown. Okay, A, complete the circuit diagram, okay, to show how the student, okay, how the circuit could be used in order to determine the EMF, okay, and the internal resistance of the cell. We know that in this type of circuit we have to connect it with what? With a variable resistor. This is the variable resistor. And also we have to measure what? The current through the circuit and the potential difference across what? The photocell or potato cell. Okay. This is easy, 2 marks. By drawing this circuit, we get the 2 marks. Okay. By connecting it with a voltmeter in parallel and with what? An ammeter in series and connected with what? A variable resistor to control how much is the current passed through the circuit. Okay. Easy. Now let's move on. Here what they ask in the next question. The student complete the experiment and plot a graph showing the relationship between the potential difference V and the current I as shown. We know that it's a straight line with negative gradient, okay, the relationship between voltage and the current, and don't forget the current here in milliampere, okay, we have to be careful here. Use the graph to determine how much is E and how much is R, 4 marks. We know that we have to draw a straight line, and this straight line is the BISPHES graph, okay, and the y-intercept, okay, is what? Is exactly the y-intercept is the EMF. Thank you, Hamza. And what also the gradient or the negative gradient is the what is the internal resistance. So if we draw the BISPHET line, it will be somewhere like this. Okay. You will use your ruler. You are better than me, okay, in your drawing. Then I'll choose 2 points. Okay, for example, this point. Okay, clear 2 points. Okay, this one and somewhere here. Okay, and find how much is the gradient. Okay, and after I do that, I will find how much is what the y-intercept and the internal resistance. So the EMF is equal to the y-intercept, exactly the y-intercept, which is equal to approximately, okay, don't forget to, it's not good to put a dot like this big dot, it's supposed to be small, okay? So it will be approximately 0.28 volt, okay? And by finding the gradient of this line, okay, a gradient, okay, negative gradient equals what? The internal resistance, so it will be delta V over delta I, okay? And it's, so here the y-intercept 0.28 volt, and the gradient, I have to choose these 2 points clearly, okay, from my straight line, okay, and there's range of the accepted answer. So R equal, let's say, this point, it's 0.28 minus 0.12 over the value of the current, which is 0.4 minus 0, all multiplied by 10 to the power of -3 because it's in milliampere. And by using calculator, how much is the answer here? It will be exactly 400 ohms. Yes, 400 ohms. Thank you. Write this down, take a screenshot. Next part, C. The 0.4, it's the here. I find the change in y-axis, 0.4 minus 0. I take the y-axis over the x-axis. Okay, yes, I know it's 0. I remove the negative sign. There was negative sign here, and I remove it. If you notice it, this, I remove the negative sign, so I switch these axes. Yes, it's supposed to be negative, but it's negative the gradient, so we cancel it out. You are welcome, Salma. Shahad, did I answer your question? Okay, Yes, you are welcome. Now, in part C, what do they ask here? In a separate experiment, two resistors with equal resistance R are connected to the battery with the internal resistance R, okay, with the two resistors firstly in series here, as you can see in diagram A, and in second in arrangement in parallel as shown in diagram B. So in series, in parallel, here we have same current, halfly shared voltage. Here we have same voltage. Each one has different, same current, identical, but not the same current that passed through them. That means twice the current that passed through the whole circuit. And here it will be, okay, half the current passed because we have two resistors in series. So what they ask, explain whether or either, okay, of the two arrangement lead the greater value of the potential difference. Okay. Now, if I have a potential divider here, okay, sorry, a potential voltmeter connected here or here, doesn't matter, okay, and the same thing here, okay, that means this voltmeter that I connected here or here, okay, it will give me how much the reading of what of the voltage across the resistors or across what the battery. Now, since we are talking about potato cell, okay, that has internal resistance, now we know that the voltage is equal to the EMF minus I multiplied by the internal resistance. And whenever the current that the circuit that has more current, that means the dropping voltage I multiplied by internal resistance, it will be greater. So that means the EMF minus a greater value will give and leads to have lower voltage across the battery. Okay, let's repeat that again. They ask about which one has a greater potential difference across the battery or across the connection, okay? Now we know that the voltage across the battery, okay, is equal to the EMF of the battery minus I, the current that passed through the circuit, minus, multiply, sorry, the internal resistance of the battery. Now we know that whenever the current is higher, as you can see here, whenever the current is higher, the potential difference is what? Is lower. It decreases. Whenever the current is higher, the potential difference is increased. Why the potential difference increase? Because this value, I multiplied by R, okay, R is constant, but I increases. That means the product of I times R, which we call the dropping voltage, will be higher. That leads that the EMF minus a higher value, it will lead to lower voltage. Now, they didn't ask about lower voltage, they ask about higher voltage. Now, which one it will be the higher voltage? The one in series, okay, or the one in parallel? Who can tell me and why? Which one has higher voltage read? The one in series or the one in parallel? Yes, of course, the one in series. Why the one in series? Because the current here, the resistance is more. That means there is less current. So as the current, as this value I decreases, that means the product of these two will be less. So that means EMF minus a smaller value, it will be greater what? Voltage. Okay? Yes, one of your answers, Ammar, in series circuit, the total resistance is greater than in parallel, so which that means less current pass through the circuit. Okay, so because the EMF is the same, okay, and the internal resistance is the same, the dropping voltage, it will be less, giving a higher voltage. Thank you, Ammar. Other answer from Hamza, diagram A has a higher potential difference because the combined resistance is greater. That means the greater value of the resistance are connected in series. Okay, I know not full answer. Yes, exactly. So if we look to the mark scheme here of this question, you will see that, let me open it. You will see that we have several ways to answer this question. Where is it? Yeah, this one. What they ask here, there's two different ways, this one or this way. Okay, in series, okay, A or diagram A, there is greater what resistance than in parallel. So the resistance is twice than the resistance here. Okay, in parallel it will be R divided by 2. So greater current in parallel or less current in series. So as EMF and R is the same due to the formula V equal EMF minus IR or EMF equal V plus IR. So there is less voltage in parallel, okay? So the terminals or the potential difference, okay, the terms of potential difference is greater in what? In series or in A. That's a way of explaining the answer. Another way, in series, greater combined resistance, R and EMF is the same, V equal, he derived the formula, EMF times R over R plus small r. The terms of the potential difference is greater in what? In series. So I will choose one of the ways to answer here. Okay, the first method, what I'm going to say. In series, the combined resistance is greater, between brackets 2R, than in parallel. So less current passes the circuit, making less dropping voltage due to the internal resistance so the potential difference across diagram A is greater due to V equal EMF minus I times R, since E and small r are constant. Are constant. Unlike this, we finished the whole exam except the multiple choice questions. Now let's return back to the multiple choice questions and answer them. Okay, take a screenshot if you please. And let's move on to the multiple choice questions. Yes. They are very easy questions actually. Okay, the multiple choice questions, they are very easy. Okay, in this year. I don't know why. Usually they are not that easy. Not all of them. Okay. So what they ask here. Okay. First question, which one of the following of the SI unit is the unit of the electromotive force? We know it's volt, D. Next question, okay. A filament lamp is a source of unpolarized light. A polarized filter is placed between a filament lamp and observer. The filter is rotated in the plane perpendicular, okay, to the direction of the light travel. Which of the following observe as the filter is rotated through an angle of 90 degrees? It's unpolarized, and one polarized we have. So as we rotated, the light intensity doesn't change. So, okay. Tamam. So the light intensity doesn't change because we have unpolarized light and we have only one filter. Okay, next question. What do we have? When a guitar string, okay, when a guitar string is plugged, okay, a sound of constant frequency is heard. The wave produced in the vibrating guitar string is what? Of course, it's what? It's a string. So it's a transverse. And it's what? It's a standing wave, stationary wave. So the answer is what? Is D. That's question number 3. Question number 4. Which of the following has the largest de Broglie wavelength? Now we know that de Broglie wavelength equal Planck constant, okay? Planck constant divided by what? Divided by momentum. So that means Planck constant divided by mv. So to have largest, biggest wavelength, okay, that means the smallest mass and the small speed, okay? So electron has a smaller speed, smaller mass than neutron, okay? And a smaller speed, that means 3 times 10 to the power 5, not 4 times 10 to the power 5. So the answer is what? The answer is A. Thank you, Noor. Yes. Thank you, Hamza. Yes. Okay. Next. Which one, okay, question number 5, which of the following graphs should show the current varies with the potential difference of the negative temperature coefficient of thermistor? Now we know that negative temperature coefficient, that means as the temperature increases, the resistance what decreases. Now we have a graph, okay, for voltage current, because the resistance decreases, that means it has less gradient. It will be like this, but here they switch the axes. Here they switch the current and the voltage axis, so the answer is C. Yes, thank you, Noor. Thank you, Hamza. Okay, tamam. Next question, question number 6. What they ask: a string is stretched between 2 fixed points and set into an oscilloscope. Okay, oscillation. The frequency of the vibration and the string is not depend on. Okay. Now we know that the tension, okay, and the frequency depends on certain points according to the formula that they give it to you in the end of the booklet of the exam here, but it doesn't depend on the length. Okay, it depends of the, okay, the frequency does not depend, okay, of the amplitude, of the mass per unit length, of the tension. It depends on these, okay, but it doesn't depend on, sorry, on the amplitude. It doesn't depend on what? On the amplitude. It depends on the length, but doesn't depend on the amplitude. Okay, good. Okay, the amplitude, not the length, sorry, the amplitude. Question number 7. An ultrasound transducer is placed on the surface of solid object, okay, as shown, okay. A pulse, okay, of ultrasound transmitted into the object. The pulse is received by the transducer 50 microseconds after it emitted. Micro, that means times therefore of -6. Which of the following can be used to calculate the speed? Now we know that speed equal distance over time, and the distance is here because they echo. That means multiplied by what? By 2. So which one is the answer here? Yes. Or you divide the time by 2. Yes. So the answer is what? The answer is B. Exactly. The answer is B. Okay. So here it's, instead of writing 50, they write 25, but that means 50 divided by 2. Yes. So the answer is B. Thank you, Ammar. Thank you, Hamza Rahal. Next question, question number 8. What do they ask here? 2 copper wires of identical cross-section area are placed in series, identical cross-section areas. Okay, which one of the following could be different for the 2 wires? The charge carrier density is constant, okay? The current is the same since they are connected in series. The drift velocity, they have to be the same because they are copper. The potential difference, maybe one is longer than the other a little bit. So the answer is what? Is D. Okay. Mariam, so how did they, okay, look here, yeah, Mariam, okay. The distance is how much? Is 1 centimeter. That means 2 times 0.1 divided by what? 50 times 10 to the power of -6. Instead of writing 50, what do they write? They divide by 2, divide by 2, right? They wrote 25. Okay, did I answer a question? Okay. Question number 9. The definitions for current and voltage are both includes. Includes what? Yes, they include the charge because current is the rate of current passed through, charge passed through a wire every second, okay? And the potential difference is the amount of energy given for each one charge, okay? So both of them, they are, yes, thank you, Noor, thank you, Hamza. Number 9, the answer is A. Last question here, okay? It's a confusing question, they repeat it in different way. Question number 10. The diagram shows how the displacement varies with the distance along a stationary wave as the two instant of time. So this is a certain point, a standing wave, and this is another what? Another instant. Okay. What do they ask here? They give us questions. Okay, that which one of the following is not correct? Point X and Z are antiphase. It's obvious that X and Z are antiphase because one is in the top and one in the bottom. Okay, points Y and Z, these are the same amplitude. No, they don't have the same amplitude. This one here and this one here. Okay, different amplitude. Point Y and Z, they have same frequency. Of course, all of these points, they have the same frequency because we are talking about the same wave here. Point Z is antinode. Okay, so it's correct. Okay, so which one is not correct? The answer is B for question number 10. Okay, they don't have the same amplitude. What do you mean, Shahid, by okay, yes, thank you. Muhammad, what do you mean by C here in this question 10? Okay, Allah ya'tikum al-afiyah. That's it for today. See you next time. If you have any question, you can stay online. If you don't have a question, you can leave. Assalamu alaikum wa rahmatullahi wa barakatuh.